Good afternoon, everybody. Welcome to MODEX, and welcome to Modernizing DC Operations for Seamless Delivery. My name's Luke Nuber. I'm a Senior Account Executive with DLN Integrated Systems. Those of you that are operators in the room or associated with an aging legacy distribution center, maybe think back to the time that you were designing or introduced to that building, and maybe this image conjures up some thoughts about how that was described to you at the time. Words like fast, agile, efficient, powerful. And that was probably your feeling and your vision of that DC when it was built. And as time has gone on, maybe you started to look around and realize you're in a little bit different race than you thought you were at the time, and that the competition has got a little bit of a competitive advantage compared to what your capabilities are today. When we think about those pressures of the market, which are constantly evolving and changing, there's a few key aspects that come to mind. Speed is certainly one, right? Everybody wants faster fulfillment. Of course, everybody wants to get what they ordered, so accuracy is always a huge pressure as well. Assortment is something that a lot of companies are dealing with on a daily basis. As we all want to offer more and more to our customers, those assortments continue to expand. And everybody wants everything cheaper all the time, right? So there's always pressure for a low cost. But if you're dealing with a legacy DC, it was maybe built at a different time where speed was not a factor, and you're dealing with long, slow cycle times and struggling to keep up. You're probably doing a lot of manual processes in the building and subject to human error. You're probably space constraints as well. If your building wasn't built for that huge assortment, space can become a huge issue as our facilities age. And lastly, those processes are becoming more and more inefficient, and labor intensive. Sounds pretty bleak, so probably we should just give up, right? No, of course not. Maybe we wave the white flag? No, this is the modernization session today, and we're going to talk about how we can avoid waving the white flag, avoid going and building that new DC, and really capturing a lot of value out of our existing systems. A couple key takeaways I want you to have from the session today. First of all is just to understand really what best practices are and what good looks like, and how do we think about our operation as we optimize to meet those best practices. I'll talk about technologies that are really well suited more than others to modernization environments. And then lastly, just what's the overall case and how do we go about executing a modernization project going forward. So let's dive into those best practices one at a time. First one is speed. And again, the main way we think about speed is really talking about cycle time. And cycle time can be anything from the time that someone clicks by on a website to when the order leaves your DC, or we can drill in and talk about the cycle time of an individual process or an individual step. But regardless of what level of magnitude we're looking, one of the key aspects you should try to think about if you're looking to go faster is to look for opportunities to process in parallel rather than serial. So when I'm talking about serial processing, I'm taking the steps of a process and doing them one after the other. But if I can do those in parallel and have multiple associates working on that process at the same time, I can cut the overall cycle time in half. So if you think about picking an order, maybe a blue item, a yellow, and a red, if I go pick all three, that takes a certain amount of time. But if I grab two friends and we each go grab one and we come back and meet together, that's a much shorter cycle time process. So one way to speed things up is by looking for opportunities to go in parallel. The next is to think about how our systems interact with the workflow of our operations. Historically, WMS systems have looked to do things in very large waves, large batches of work, because that gives us a great opportunity to optimize. And while that's great, it also can delay the cycle time of an order. So if an order gets placed after the last wave was released, it may be hours before that order can even be started on going forward. So a lot of companies are gravitating to more of a waveless environment and warehouse execution software that can optimize and select the best order as each step of the process or each next order is released without building up this big wave. And that can allow especially expedited orders to flow through the system much faster without this long cycle having to take place. Another way to cut cycle time is by getting away from person to goods processes where, again, I've got that long serial process that's got to go through my full warehouse and bringing the goods to the person. If we look at productivities of warehouse workers, walking is typically the highest labor component of any picking process. So if we bring the goods to the person, we cut out the walking and thereby reduce the cycle time by quite a bit. Shifting focus to accuracy, technology is our best recommendation for helping to be more accurate in the warehouse, and there's a few things we can highlight here that are helpful. One is just pick-to-light systems or put-to-light systems that give a nice visual indicator of what item to select and the quantity, or where to put an item in the quantity. These have been on the market for many years, but they're still very popular because they work and they're a great way to improve accuracy. A lot of systems now will also have a nice graphical user interface that's capable of displaying a picture of the item. So look for those systems as well. That's a nice double check. As I'm picking, I can also visually check, is this the actual item that I'm supposed to be picking, rather than just grabbing what's in the slot. Lastly, goods-to-person systems, again, are a great way to promote accuracy because the system is bringing me a single item and I've got to pick the item that's presented to me, and that was selected robotically. So there's a much higher chance that that's the correct item that's arriving. And a lot of these goods-to-person workstations layer on the graphical user interface with the picture and the put-to-light system. So we've got multiple layers of verification to make sure that we're picking that correct item and getting it in the correct order. When you look at assortment, I'll give a little example here of how our operations get challenged as the assortment grows. So again, picture that order with one yellow, one red, and one blue item. And when my assortment's really small, I don't have many SKUs in the building, I've got a nice short pick path to get to those three items and complete my order. As I start to expand my assortment, the number of items I don't need to pick starts to get between those picks that I do need to make, and my pick path starts to extend. And of course, you can see where it's going. As my assortment gets really large, I start to walk a really long distance in order to pick those same three items. So how do we combat that? The main tool we've got against assortment growth is high density and high selectivity storage. What do I mean by that? Let's look at a couple examples here. First is an example of high density, low selectivity storage. So these items are very dense. They're right on top of each other. There's no space between them at all. So that's the high density part, but unfortunately they're on top of each other and I've got to dig to get to the item I want. So the selectivity, we would say in this case, is low. The opposite of that is traditional selective pallet rack, where I can get to every pallet, I know exactly where it is, but there's a ton of airspace, big wide aisles in this system. So that's a low density system even though I've got high selectivity. So what we want to get to is systems that have high density and high selectivity systems like the goods-to-person solution that's pictured here. These totes are all individual locations. I can pick exactly which one I want robotically and bring it to a station. So I've got both the density and the selectivity in this application. This is an automated example, but there are also manual alternatives on the market that do the same thing. So in this case, we've got a bunch of little cubbies that are stacked side to side and also front to back, and I can get to exactly which location I want. I've got a ton of locations available to me, and I get that selectivity, but also the density that I'm looking for. So if we go back to our example of the growing assortment, if I take that same assortment, the same number of dots, and I apply something that's high density, high selectivity, you can see how my pick path has gotten vastly shorter. I can still get to those items in a much lower walk distance, and also I've created space on the margins to bring additional items into my facility. A couple different areas when we talk about ways to reduce our cost. First one is labor. That's always a huge component of any distribution P&L. And what we like to focus on in a modernization setting is automation that is flexible and scalable. The goods to person solution pictured is one example. Those are great for being able to build modularly and go into spaces that are maybe not ideally fit, and you can make different shapes and fit those into spaces within an existing warehouse. And you can also add storage and throughput capacity independently from each other, so as your business grows, you can scale those up as needed. Other examples of this are the AMRs and AGVs. Again, those go into existing infrastructure. I don't have to do a lot of modifications to my facility to make those work, and I can add throughput capacity as my business grows. Packing is an area that's often overlooked, but there's a lot of opportunity to reduce costs in here as well. We can look at labor costs in packing with automations like auto baggers or auto box erectors. You can also attack this from the materials angle. Again, bags are much cheaper than boxes, and also if I need to do boxes and doing a box on demand type technology, that reduces the corrugate I'm using by making the box exactly the size I need. That not only reduces the corrugate for the box itself, but the void fill that I've got to put in it. And then all of these solutions, because I'm only making the package as big as it needs to be, they help me reduce shipping costs as well, because we're not shipping excess air in the process. So now that we know some best practices, time to go build that new greenfield DC, right? That's great, but you're going to need a few things. First thing is the reason to build a new node to begin with, right? So usually new network nodes aren't available to companies unless they're having a huge growth rate where you really need that capacity. Or maybe we're going to expand into a new geography, and that can help us get there. Those get justified typically just a slow growth rate. You're likely to get turned away. You're also going to need a ton of capital, 20 to 30 million per 100 square foot. It's a nice rule of thumb for those, and sometimes even higher. You're also going to need a lot of time. So picture 3 to 4 years from initial concept to when you might actually be live out of a situation. So you got all those things. Maybe a greenfield's a good solution. But a lot of us live in the real world where there's other priorities that are in the way of that nice, shiny new building. First is capital constraints, right? So your company's probably got other things that they want to do with $60 million than build a DC. So whether it's investing in stores, new capabilities for the business, a lot of competing priorities for those capital dollars. And also capital is very expensive right now. This is probably a temporary issue, but borrowing costs are higher than they've been in a while, and that makes it even harder to get those projects justified. Also, again, that time factor. If this is a competitive issue for your business, you probably needed those capabilities yesterday, not 3 to 4 years down the road. And lastly, it just makes good business sense if you've got assets that are already part of your company to make good use of those and get as much out of them as you possibly can. So, for all those reasons, we're really in favor of modernizing when you can. So let's talk about how do we actually do that. First step in a good modernization project is to do a couple different analysis. One is a gap analysis, but I want you to also think about a capacity analysis as well, and I'll explain the difference here. So if we take a kind of high-level graph here and graph time on the x-axis and our capabilities on the y-axis, the blue line sort of represents our current state baseline capabilities, and the green is where the business would like to get to over time, which is represented by that dashed line, right? We're improving over time. And the gap analysis is really going to look in depth at what those things that you need to add, capabilities, technologies to get from where we are today to where we need to be in the future. And that's a great first step, but it also can lead you a little bit down a wrong path because if we start thinking about that's the investment I need to make, there's opportunities to do better, and really that's by doing a capacity analysis as well. And that's going to help us understand what the true capacity of our existing assets are rather than just what we're getting out of them today. And a lot of those additional capabilities can be obtained at a very low cost. The benefit to that is the required investment is now less because I'm going from this upgraded capabilities to my desired state rather than where I'm at today. And then that, in turn, a lower cost is just going to help those projects be a lot more justifiable because I'm not asking for as big an increase in my capabilities to get there. Let's dig into the capacity analysis a little bit more. Again, a common mistake here is to go out and measure the rate that you're getting through your current system today, whether that's a sorter, a piece of equipment, what have you. We want to dig a little bit deeper than that in a couple key areas. The first is the machine rate itself, so want to understand what that piece of equipment is capable of doing when fully utilized, and also look at opportunities to upgrade the speeds and the throughputs of that equipment at a low cost. So you may have a conveyor sorter in your building that's running 300 feet a minute, but that doesn't mean that's not what it can go to. They may have just engineered it that way to start. So maybe that can be turned up to 500 feet a minute and you get more throughput through an existing piece of equipment. We also want to understand capacity from a time standpoint. So when your operation goes on break, takes lunch, various ebbs and flows in the day, that's all wasted capacity at the end of the day. So we want to look for opportunities to work through breaks to fill those valleys with better work management and get more capacity out of the system in that way as well. Last one is space. Look around at your existing assets and understand where are opportunities to get more capacity in space as well. So looking at things like, could I add more workers to areas of the operation? Is there unused space in the building? Usually looking up is a good indicator there. A lot of buildings will just use things at the ground floor we may be able to build up. Or look outside the four walls on your same property. Maybe you can bump the building out and look for space that way as well. Another piece of a good starting foundation for modernization is a maintenance audit as well. You want to look at your existing infrastructure to understand how old it is, what kind of condition it's in, and if you've got obsolete components in the operation where you can't get spare parts for those subsystems. Those might be ones you want to think about upgrading. Especially with those upgrade subsystems, understanding compatibility to be upgraded is another more detailed analysis you might want to take on and understand if I can even upgrade this subsystem without upgrading something else. Maybe my controls have to be upgraded to upgrade the hardware. So that can add to the cost and complexity of an upgrade as well. But once you got this information, you want to build that into your overall work plan, understand if you're going to do it during the project or if that's something you're going to be facing down the road as the facility continues to age. So now, as we look at what type of equipment fits well with a modernization type of project, the key theme here is to focus on high efficiency equipment and processes. And when I say high efficiency, I mean processes that are very productive and also have a nice density to them are going to be the best to fit in a modernization environment. First one I want to talk about is collaborative AMRs or cobots. As you walk around the floor here, you'll see dozens of different companies with dozens of different form factors and functions on these technologies. But the key theme I want to hone in on here is ones that can go into existing infrastructure and work alongside human workers to get them some higher productivity. The advantages of these are, again, they frequently can go into your existing pick areas, your existing infrastructure without a lot of modification. And they can improve the productivity of your human workers, sometimes around 2x increase in productivity. They're also great for modernizations because they're very scalable. So if you are capital constrained, you can buy just enough equipment for your current needs today and add it as it grows. There's also a lot of opportunities to lease this technology on the market or buy it as a service. So again, you're only paying for what you're using today rather than some conveyor system or other piece of technology that you have to grow into over time. Want to consider a few things carefully before investing in these. First of all is just the overall business case. Many of these applications take 4 to 5 robots to replace one human worker. so that can be expensive and potentially hard to justify, so do your math there. You want to understand the maneuverability of the bots, and this varies widely across that market. But you want to understand if they're going to work well with your current aisles. Can people pass the bots? Can the bots pass each other? Can they navigate the corners around the ends of my aisles? So all important things to understand there. Lastly, we're going to be adding to the total number of bodies in the system. If we're taking 4 to 5 bots in for each person that comes out, that's a net increase no matter how you slice it. And as they start to interact with each other and interact with people, they start to slow down. So you want to understand how much congestion is going to impact your case. Doesn't mean it's a bad application, but you do want to factor that into your overall business case and your returns, congestion factors if you're going to have them. A couple of tips to get into these if you're interested first is to try a pilot, carve off a smaller area of your operation that's in the real environment as best as you can. Let them run around for a while, see how it works with your actual business and your actual equipment before you then can scale up and invest bigger into that technology. The other thing that's a great tip with these is to leverage them for functions outside of picking. So that could be using a transport function in and out of an area. It could be doing replenishments, bringing cases in. But those other functionalities will increase the value that you're getting out of the technology, and allow you to justify them easier and getting a better benefit from them. Next one that works really well for modernization environments is goods-to-person systems. Again, a ton of different form factors and functions on the market, but we're talking again about dense storage systems that bring items to the picker to be picked. Advantages to these are that they're very productive, especially for slow movers in a high SKU environment, just like that large assortment example we just looked at. If that's ringing a bell, if that's the environment you're in, those are great items to eliminate walking from the process and get a high benefit from the productivity of the system. They also have a great density of pick faces, so that helps you better utilize that space by compressing your inventory and also, in most cases, going vertical and using that vertical cube that you may not be using today. We can also divide the totes if you've got smaller items. You can split that tote up and get even more pick faces, more SKUs into an individual tote. Lastly, they're great for being able to expand modularly, so we can add storage, we can add bots. If systems have lifts, we can add lift capacity as well, individually and separately from each other with a lot of these systems, so that again allows us to keep our initial investment low and grow the technology as our needs grow. Couple things to watch out for with goods to person. First is the rate of the technology versus the rate that a person can actually work with it. A lot of companies will publish the machine rate of the equipment, and those can be extremely high rates, but in a lot of cases more than a person can actually reasonably produce over the course of a day. So you want to put some thought and derate those productivities that might be published by a manufacturer to something that's a little bit more realistic to your process and your people. Next thing to watch out for is the slotting strategy, so making sure that we've got the right inventory in the system and that what's put in there in real life is what it was designed to do. So there's a lot of different ways we can design these things for throughput, for storage. You want to align that slotting strategy to the intent of the system. Also, understand that there's a lot of different solutions on the market. They've all got their strong suit and they've all got their weak points. So you want to do your research and understand a lot of different ones and find the one that's best for your application. Lastly is the characteristics of your building. Some of these technologies are dependent on things like floor flatness. Some do better in high ceiling environments than others. So you want to think about the building as well as just the technology. Because of all those differences between the different technology providers and manufacturers, this is a great area to engage a third-party professional that's experienced in this market and understands the difference between the various technologies. Last technology I want to highlight is 2D pallet shuttle systems. These use shuttles to store pallets very densely to each other. Again, like the goods to person, very scalable technology. I can add storage, throughput, and lift independently from each other and in various configurations. If I compare these to the kind of the legacy historical ASRS unit load crane, uptime can be much better with these because if we do have a maintenance issue, you're just losing a shuttle, which is one spot on one floor. We're not losing an entire aisle of productivity and throughput. You can also put pick tunnels through the system, as is shown in one of these images, so we can actually have pickers working in what's otherwise a solid grid of inventory, and having the system automatically replenish those pick faces in addition to the storage that's going on above. We've had really good success with finding these to be very justifiable, even at standard building heights. Typically, ASRS systems, you have to go up 60, 80, 100 feet in order to justify the technology. And for these, not typically the case. There's a good business case to be had 30, 40 feet up. With these, the main thing to consider is just whether you have an inventory profile that's fitting of dense storage at all. So if you've got a lot of pallets of a lot of different SKUs, these can be a great solution. If not, maybe not so much. As with all automation, pallet quality is really important, so we've got to have good quality pallets going through the system. And lastly, you need to understand, again, as with any automation, what your peak looks like. If you've got a very spiky demand profile, you may need to invest in more throughput capacity to keep up with those spikes, or it may not be a good fit for your business. As I mentioned before, these are very easy to justify. A lot of times it can be done on space savings alone without even taking into account productivity benefits that you get from it as well. So now that we've talked a little bit about technologies that fit, let's dive into how do we make it actually happen. And I think when you're thinking about modernization, planning it's important in any project, but it's even more important to make a modernization project practical and something that is going to be a success at the end of the day. The first thing as you're thinking about how to plan these projects is to think creatively. They don't go smoothly. The path is not always as direct as a greenfield project. So you want to really expect and anticipate some difficult phases are going to be part of the project. And you may have to, like a game of chess, do some setup moves in order to get to the desired path. So I might have to move some volume to offsite storage. I might have to shift volume to other network nodes in my network if I've got multiple distribution centers in order to get that volume down and out of the way in order to do some modernization. You might have to do things like moving work areas to a temporary location, running temporary conveyor lines and things like that in order to step through the process and get to the end goal of the future system. Also with that difficult plan, it's really important to start early in the process and give yourself a lot of time to work through each step in detail and make sure that plan is really sound before you even do the estimation and the budgeting for the plan. Understand all those chess moves, those workaround pieces, and make sure those are actually part of your budget, both from a cost standpoint as well as a time standpoint and the overall schedule. It can take 3-4 times longer to do something in a modernization environment because we've got to make all of those interim moves to set up the final installation. And lastly, it's just something that you just don't want to do in a rush. That's a way to make bad assumptions that are going to, at the end of the day, end up being problems with your project and delaying you. So with that environment in mind, just be flexible in the way you set your project up. It's going to be messy. It's going to be harder to execute. So build in contingencies even on top of what you would normally do for a project. An extra 10 to 20% time of the schedule. Just have blank periods in your schedule where you can use those to catch up if you need. And from a budgeting standpoint, same thing. Extra 5 to 10% on top of normal contingencies, probably a good rule of thumb for a modernization, because there's going to be as much due diligence and legwork you do up front. There's going to be some things that you didn't foresee coming, and it's good to have that extra contingency in your budget as well. So with that, I think, again, just want to reiterate that it's a really powerful alternative to modernize, to use more of your existing assets, can make projects and capabilities much easier to afford, and much more realistic for companies that have constraints as most companies do. Again, start with those optimization best practices in mind, and strategically look at what are the aspects of your operation that are behind the times that need to be upgraded in order to keep up with your competition. Think about those enabling technologies that we talked about, high efficiency, high density, really important for modernization technologies. And then again, take that time, make a really good plan, be very thorough with that, and I think you'll be set up for success. With that, any questions? We have a few minutes left. All right, well, I appreciate the time. Enjoy the rest of the show. Feel free to come up and ask any questions after the fact if you didn't get the chance or didn't want to in the big group. Feel free to stop and see us at the booth as well, and enjoy the rest of the show.